Hello everyone, my name is K. Ranjit Kumar. Today I am going to present a seminar on probability theory and stochastic process. Especially I am focusing on the definition of the probability and the properties and axioms of the probability. Basically, the probability definition is the probability is a measure of how likely an event to occur when we perform a random experiment. It provides a way to model and quantify uncertainty in various real-world processes, such as rolling dice, drawing cards, or predicting future outputs. We represent the probability of an event E as P of E. It applies in any situations where outcomes are equally likely, or it can be modeled with well-defined probabilities. The classical definition of a probability is, in simple cases where every outcome is equally likely, the formula for probability is P of E is equals to number of favorable outcomes by total number of outcomes. For example, a fair six-sided die has six outcomes. There 1, 2, 3, 4, 5, 6. Getting of 4 is 1 by 6. Here the total number of outcomes is 6 and the favorable outcome is 1. So it was 1 by 6. These are the three main axioms of the probability: non-negativity and normalization, countable additivity. Here, the first axiom is non-negativity. The probability of any event is non-negative or real number. It means the probability of any event cannot be negative. Mathematically, P of A is always greater than or equal to 0. P of A is always greater than 0 for any event A. The second axiom of probability is normalization. The probabilities of the entire sample space is always 1. It means the total probability of the sample space is always 1. P of S is equals to 1. Here S is the sample space and P is the probability. And then the probability of an impossible event is always 0. It means the probability of an impossible event, like getting a 7 on a six-sided die, is 0. It means P of pi is equals to 0. P of null set is equals to 0. It can be called in those two ways. The third axiom of the probability is countable additivity. If a sample space A has m events, n is equals to 1, 2 until at n, where n may be infinite, and if all the events are mutually exclusive. Then, if multiple events are mutually exclusive, they cannot happen at the same time. So, the probability of their union is the sum of their individual probabilities. Here is the notation for that: P of A1 union A2 union until union An is equals to P of A1 plus P of A2 plus and so on P of An. In words, this states that the probability of the union of n number of mutual exclusive events is equal to the sum of the individual event probabilities. To simplify this expression, consider two disjoint events A and B. For example, rolling a die for getting 2 and 5 on a die. Then P of A union B is equals to P of A plus P of B. Here we will get minus A intersection B also, but the A intersection B will be 0. Why? Because the event A and B are not happen at the same time, so they will be 0. There are 8 properties for the probability. The first property of the probability is 0 is less than or equal to P of A less than or equal to 1. It means the probability of any event A lies between 0 to 1 inclusive. Here, when the P of A is equal to 0, if an event is impossible. If P of A is equal to 1, then we can know it as certain event. It means the any event, the range of probability is always between 0 to 1 only. The second property of the probability is the complementary rule. The probability of the complement of event A is equal to 1 minus the probability of A. Here the A represents the event that A does not occur. It means the probability that event A does not happen is P of A bar is equals to 1 minus P of A. It is the condition for the complementary rule. And the third property of the probability is subset rule. If an event A is a subset of B, then the probability of A is less than or equal to the probability of B. It means if A is part of B, then P of A is less than or equal to P of B. Otherwise, if B is the subset of A, then we can write as P of B less than or equal to P of A. The fourth property of the probability is addition law. For any two events A and B, this formula gives the probability that either A or B or both occur. It means for any two events A and B, the probability that either happens or both. It was denoted as P of A union B is equals to P of A plus P of B minus P of A intersection B. This is the addition law of probability. The fifth probability, the fifth property of the probability is difference rule. This gives the probability of event excluding the part that also lies in A. In other words, the part of B that is not common with A. It means the probability of the part B that is not in A. We can write it as P of A bar intersection B is equals to P of B minus P of A intersection B. The sixth property of the probability is mutually exclusive events. It means if the sample space is partition by into mutually exclusive events, P of A1 plus A2 plus until An is always equals to 1. If the sample space has infinite number of events. The seventh property of the probability is null and universal sets. The null event is also known as impossible event, has probability 0, and the sure event, entire sample space has the probability 1. For null set R, P of pi is always equals to 0. For universal set S, P of S is always equals to 1. Here, the P of pi is impossible event and P of S is certain event. The eighth property of the probability is equally likely events. For equally likely of any events in S, the probability of each event is Pi is equals to 1 by n, where I is equals to 1 to until n. It means if there are n equally likely outcomes, then Pi is equals to 1 by n. Here, if all events are equally likely, then the probability of each event is the reciprocal of the total number of outcomes. The summary of key points. The probability gives a structured way to handle uncertainty. The three axioms guarantee that probabilities are meaningful and consistent. The properties helps us to calculate probabilities for more complex events and are used in various practical applications such as risk analysis, machine learning, and data science also. The probability theory is fundamental to understanding randomness in real-world processes. These basic rules are the building blocks for more advanced topics such as stochastic processes, Markov's chains, and queuing theory. Thank you guys. Thank you for paying your attention.